Hello students, so today we are here again to continue our topic system of particle and rotational motion. Today we will take the topic angular acceleration and moment of force. So first we will discuss about angular acceleration. As we know, what is angular velocity? The rate of change of angular displacement is known as the angular velocity. Similarly, the rate of change of angular velocity is known as angular acceleration. It is represented by a symbol alpha. So, rate of change of angular velocity is known as angular acceleration. Means alpha, the symbol of angular acceleration, is equals to d of dt of omega, where omega equals to angular velocity. So, as in linear motion, the rate of change of linear displacement is known as linear acceleration. Similarly, the rate of change of angular displacement is known as angular acceleration. And thus there is a relation between linear and angular acceleration. As we know, relation between linear velocity v and angular velocity omega for an object describing circular path is v equals to r omega, where r is the radius of circular path. By differentiating the term v equals to r omega with respect to time, we get d upon dt of v is equals to r d upon dt of omega. The expression further gives us the relation A equals to r alpha, where A is the linear acceleration of the object and alpha equals to angular acceleration of the object. Now we will discuss the torque and the angular momentum. First we will discuss the torque. It is also known as moment of force. The rotational analog of force is known as torque or couple. Means when a force on a body is applied in such a manner, in such a direction that the body starts to rotate about an axis passing through it, then we can say that there is a force which tends to rotate that body about a axis. Consider a mass particle at position r with respect to origin. As shown in figure. A force F acts on the particle in the direction shown in figure. Then moment of force for the particle can be given by tau equals to r cross F, where tau is the moment of force or torque, r position vector of particle from origin, and F force applied on that particle. Moment of force is a vector quantity as it is clear from the equation. So it is clearly given by tau equals to r F sin theta, where theta is the angle between direction of force and the direction of position vector of the particle. So we can write here theta, the angle between force on particle and position vector of particle, where r is the magnitude of the position vector. The dimensions of torque are m1, L2, T minus 2. The SI unit of torque is Newton meter. So it is clear to you that the torque can produce rotation of a body. So you can say a force applied on a mass particle or at the edge of a body tends to rotate it with respect to an axis passing through it. In that case, the moment of that force is known as the torque. Also, it is clear that when theta equals to 0 degree, torque equals to 0. It means when force on that particle is applied in the direction of its position vector or in just opposite direction to its position vector, then it does not produce any rotation for that particle. But if the force is perpendicular to the position vector of the particle, then the torque produced is maximum. So when theta equals to pi by 2 or 90 degree, torque is maximum, and that is equals to value R F. So that's all for today, and we will continue to discuss the topic with our subtopic angular momentum of the particle. Till then, good day.